Welcome to the Chapter 7.2 lesson video. Today we're going to be talking about arithmetic sequence and series. This is going to be a bit of a long video, and so I encourage you partway through, take a little bit of a break, go do something else for a moment, and then come back to it. It'll help you take a lot better notes and understand the material a lot better. So we're going to be talking about arithmetic sequence and series. So first of all, we identify what an arithmetic sequence is. We're talking about writing arithmetic rules, and we can find the sums of arithmetic series. One thing you're going to see is that this chapter has a bunch of formulas. So I strongly encourage you, get a little index card, a sticky note, something where you can keep track of all these formulas on in a nice, convenient way. All right, so an arithmetic series is a sequence in which each successive, which means each next term, differs by addition or subtraction by the same number over and over. And we'll call that number D. D stands for difference, which we call the common difference. So a arithmetic sequence is a sequence where as we increase in terms, each number next in the term has to be separated by the same amount. So a little side formula to find the common difference, we can subtract any term and the term that came before it. So that's what this little formula over here says. It says that in order to find the common difference, we can take some term and subtract the term that came before it, and that will be the common difference. So in our example here, we have -1 minus -6. And be careful if you're negatives there, but you'll see that that equals 5. So the common difference here is +5. Every time we move on to a next term, we add 5, add 5, add 5, add 5. The common difference can never equal 0. That would make sense, right? If I don't add anything, then it's never going to change. Okay, so there's our first little formula. You might want to write down on your piece of paper, write common difference, and then write that down. Would be a great idea. All right, so it says find the common difference and determine the missing terms. Okay, so let's go ahead and let's find our common difference. So you're going to take, let's say D equals -4 minus -15. Now, I like to do the plus bit here for the negative. So I have -4 plus 15, that equals +11. So I'm adding 11 each time. So my next term will be -4 plus 11, which will be 7, plus 11, 18, that works. 18 plus 11, 29, that works. 29 plus 11 will be 40. So every time I'm just adding 11. So this was plus 11 to get those missing terms once I found what the common difference was. All right, so each of these here, it says tell whether the sequence is arithmetic or not, and then explain your reasoning. Well, one way to tell if something is arithmetic is to see if the difference between any two consecutive terms is the same. So for example, here you can go 5 minus 2 equals 3. And then 8 minus 5 equals 3. And if you inspect all the other ones here, you'll see they all differ by 3, which means your common difference is 3. So if there's a common difference, that means, hey, it's arithmetic. The next one, we'll do the same idea. We'll go 9 minus 15. 9 minus 15, that'll be -6. And then we'll go 3 minus 9. That would be -6. And if you keep checking, -3 minus 3, -6 as well. -9 minus 3, -6 as well. They're all difference by -6. So our difference is -6. So yes, arithmetic. Sorry, I should probably put that one here. This is arithmetic. This one's arithmetic. All right. And then our last one, we can go ahead and check the same thing. So we'll go 4 minus 8 is -4. And then we'll go 2 minus 4 is oh, darn, this one is not arithmetic. If you look at it, you could probably figure out what the pattern is after looking at it for a few seconds, but it's definitely not arithmetic, which is all this one asks us to do. It doesn't ask us to elaborate on what it might be quite yet. Okay, cool. All right, so here we go. This is called the general explicit formula. Hey, another formula you probably want to write down. If you don't already have it written down, I would make sure you do so. So it says the following formula can be used to explicitly find the values in any arithmetic sequence. So in any arithmetic sequence, we can use this formula. It says that any term is equal to the first term plus whatever term number, so these ends have to match, whatever term number we're at, -1 times d. Now, there is a kind of alternate way to write this one, which I think is also useful. You could say an equals a sub p plus n minus p times the difference, because it doesn't have to be the first term right here. Oftentimes we use the first term because we can see the starting point of something pretty easily, but it could really be any term, AP. So the nth term of a sequence is equal to the first term of the sequence plus the number of terms in between the nth and the first term times the difference. Now, if you don't have the first term, you can use other terms as well, which is why I put this sort of alternate version down here, which just says the nth term is equal to some other term plus n minus p times the difference. And so that'll work just the same, and we'll actually use that quite often when sometimes we're not given the first term in a problem. Okay, so that's kind of an alternate version of that formula, but I usually write it this way, and I just say, hey guys, remember, this doesn't have to be the first term. We can make this any term we want. We just use the first term because that's usually the most convenient. All right, so let's go ahead and try this. It says, write the explicit rule for the nth term. Find the term. All right, so we got to write a rule. That's our first step, is write the rule. Remember, the rule with nothing plugged in looks like this. an equals a1 plus n minus 1 times the difference. So we need to find a couple things. We need to write this nth rule here. So we need to find the first term, and we need to find the difference, right? If we're just writing an explicit rule, then we can leave the n's alone. And as long as we find the first term and the difference, we have kind of this rule. And then when we want to find something like the 20th term, we could just change that to a 20 and that to a 20, plug it in our calculator and get our answer. So let's go ahead and let's try and identify our two things. When we're writing an explicit rule here, we need the two things, the first term and the difference. So let's go ahead and identify them. Here we just look at the pattern. It starts and it says given, and that's our first term is 2. So our first term here is 2. It then says, hey, the pattern goes like this. The pattern goes 2, 10, 18, 26. Now, some of you guys will just do it in your head, but I do like to see a little bit of math here. So I like you guys showing your work. So you say d equals 10 minus 2, so you're just subtracting 2 consecutive terms. They told us it was arithmetic, or we kind of assumed based on the context. You can check real quick if you'd like, but our difference here is 8. So we have our two pieces we're looking for, and we can go ahead and write our rule. So we'll go ahead and say that a sub n equals, our first term is 2 plus n minus 1. This part didn't change, n minus 1, times the difference. The difference is 8. Each time we move on, there are 8 more. All right, so there is our first part of the problem. It says write the explicit rule. That is a part of problem that would be 4 points on a problem. Now that you've written that rule, now you're going to go ahead and find a20. So you're going to go set a20. So that means our n is now 20. So we'll go 2 plus 20 minus 1 in parentheses times 8. And so this is a point when you would use a calculator. If you don't have a calculator, you can use Desmos, and you calculate it out, and you get a sub 20 equals 154. So there's two parts of our answer here. This was our part where we found the 20th term, which is what it wanted us to do. And this is the part where we wrote the explicit rule. All right, now, little side note. We know how arithmetic works, right? It's just adding the same thing over and over. This problem asked us for the explicit rule, so we had to give it. But say we forgot how to do that, and we still wanted to be able to do this, find the term part, and we know we need the 20th term. Well, this is the first term, second term, third term, right? So on. So you could just add. So you just go 2 plus 8 plus 8 plus 8 plus 8 plus 8. You could do that 19 times to get to the 20th term, and it gets you the 20th term. You didn't get the points or the credit for this part, but you at least figured out this part. So that's a good thing to kind of keep in mind as you're doing these problems is if it doesn't ask for the rule, there are kind of multiple ways, but almost always we ask you for that rule because we want you to be able to do this way. All right, so it says write a rule for the nth term of the sequence. There's two kind of different setups here. One of them's a little more straightforward, and then we'll go ahead and try this other one that's a little more tricky. All right, so the first one here, we're going to go ahead and write our formula. Now, normally our formula we said looks like this, right? Our formula we said is a sub n equals a sub 1 plus n minus 1 times d. Well, we look at this first problem here, and darn it, they didn't give us the first term. But one of the things I said was, hey, you don't always need the first term. You can use any term in place of the first term here, as long as you change this 1 in a parentheses to match whatever that subscript is. So I'm going to go ahead and make the formula a little bit different this time. I'm going to go ahead and say a sub n equals a sub 11, because that's the one I'm given, plus n minus 11 times d. So I'm getting a little tricky here. Because they gave me a little 11th term, rather than like counting backwards and subtracting 7 10 times to get the first term, I'll use what they gave me. Plug in what I know. All right, so what I know is I know a sub n equals a sub 11 is 50 plus n minus 11 times the difference they gave us was 7. And there we go. That is a formula that is good to go. Now, if you really wanted to, for some reason, you could distribute this 7 and combine like term, but that's unnecessary. This is a nth term rule, and this is good enough for us because it's kind of nice in this standard form here. All right, now my second one here is a little tricky for a different reason. They gave me the 7th term, and they gave me the 16th term. So I don't have consecutive terms, so I'm going to need to find a tricky way to find the difference. And they didn't give me they didn't give me the first term either. So I got to kind of use this trick over here and another trick to find the difference. Well, let's talk about the difference real quick. So I got to find the difference. That's going to be an important piece here. Normally, I would subtract terms. So I would do something like 26 minus 71. Well, the only issue is I'm supposed to subtract consecutive terms, so terms that are right next to each other, so like the 7th and the 8th, or the 15th and the 16th, but they gave me the 7th and the 16th. So those are pretty far apart, so what I have to do here is I have to divide by the number of terms in between, so 16 minus 7. What this does is it takes the difference between these two terms and it divides it evenly among that huge gap there. If you calculate this out, you'll get negative 45 over negative, not negative 9, over positive 9, and negative 45 over positive 9 will simplify to negative 5. So we found the difference to be negative 5. All right, from this point, you can pick and choose. You can use either of the two terms. I can go ahead and do both in order to get our answer, just like we did this previous one. So we'll say a sub n equals a7 plus n minus 7 times the difference. Or you could have said a sub n equals a16 plus n minus 16 times the difference. Either of these, when you plug in your d and a7 or a16, you'll get the same, or you get an equivalent answer. So you'll get an equals 71 plus n minus 7 times negative 5. That's a valid answer. Or you could get a sub n equals 26 plus n minus 7 times negative 5. Either of these are a valid answer. They're actually equivalent. If you were to distribute that negative 5 and combine like terms, it would simplify down to the same thing. So either of these are good, and you can leave it just like that. Yeah, so we're using a couple tricks here. First of all, we're finding the difference. Right, we're finding the difference a little bit different way. We can find the difference in any gap. We just have to divide by the number of that gap. So you do 26 minus 71, and then that's the 16th term minus the 7th term. Kind of reminiscent of the slope formula. And then we can also use any term where this a1 normally is in order to help us write our nth rule. All right, and this one says find the 17th term in the sequence. So we're going to kind of combine those two together, and then we're also going to find the 17th term on top of that. Now, these two are close enough that you could probably figure out what the third term is in between them, but let's practice what we did that on that last one. So we're going to say our difference is equal to negative 20, so that's the second one there, negative 20 minus negative 12 over 4 minus 2. All right, 4 minus 2 is 2. That's the easy part. Negative 20 minus negative 12. So that becomes plus is negative 8. Negative 8 over 2 is negative 4. So we found our difference to be negative 4. All right, that's awesome. Now, I get to pick and choose. I'm only going to do one of them this time because I don't need to do extra work. But if you did the other one, you should end up with the same answer. So I'm going to go ahead and say a sub n equals a sub 2 plus n minus 2 times my difference, which is negative 4. Okay, now I'm going to change that a sub 2 into what it is over here, which is negative 12. So I'm going to say a sub n equals negative 12 plus n minus 2 times that difference, which was negative 4. I guess on the other examples, I had kept it as a d up here when I'm showing my work. So let me go ahead and change that back real quick. Not that it really matters, but just to show where we're getting these from. And that's that d we found over here. All right, now I get to plug something in. It wants to know the 17th term. So I'm going to say, all right, a17. So my 17th term equals negative 12 plus 17 minus 2 times negative 4. And I get to plug that all into my calculator. Just be really careful with your parentheses. Negative 12 plus 17 minus 2 times negative 4. You plug that all in and you get a17 or a sub 17 equals negative 72. And there's our 17th term in this sequence. So we kind of combined all those ideas together here. If you haven't already, go ahead and take a break now. We're going to move on to another concept here that's a little bit different, and I want you to pause before you get there. All right, another thing we can do is have arithmetic series. Now, we already know series is where we take a sequence and we add them all up. Okay, so a series or a sum of an indicated number of terms of a sequence is where we take all the numbers and we add them up. So S5 equals A1 plus A2 plus A3 plus A4 plus A5. All right, that's just adding them all up. We're going to talk about some patterns that occur when we're adding up arithmetic sequences, and there's a formula we can use in order to find the sum of that sequence, or sorry, that series. Yeah, so let's go ahead and let's talk about that pattern. All right, so it says evaluate the series of the given sequence. Now, there is a really cool math problem out there, and there's a story that goes along with it. The story goes something like this. The teacher was having a bad day, and they say to their students, I just need you guys to be busy for a little bit, so I'm going to give you an assignment. I'm going to give you all the numbers from 1 to 100. I want you to add them all up, and then once you add them all up, come back to me, tell me what the answer is. So teacher goes back to their desk, and 2 minutes later, the brightest kid in class comes right up and says, hey, I know the answer. And so supposedly this is a true story about a famous mathematician, but let's talk about what that solution is. So you could take the numbers and start adding them. 1 plus 2 plus 3 plus 4 plus 5, or in the case that we're going to do here, 2 plus 4 plus 6 plus 8 plus 10 plus 12. But that would get a little tedious, especially with the numbers 1 to 100. So what this smart little person did is they realized that they could pair the numbers up. So let's look at what happens. If I pair the first number with the last number, and the second number with the second to last number, and the third number with the third to last number, and the fourth number with the fourth to last number, we're going to see something interesting. 2 plus 16 equals 18. 4 plus 14 equals 18. 6 plus 12 equals 18. 8 plus 10 equals 18. And so the story goes that the kid explained his method. He added 1 to 100, 2 to 99, 3 to 98, and he saw that they all added up to 101. So he thought about it and he said, well, 1 to 100, if I split that in half, there's 50 pairs of 101. 50 times 101, I have my answer. Or in this case, 4 times 18, which is 72. Hey, now we have our answer. All right, and this is kind of what inspires that formula that we're going to use to add up our arithmetic series. And so here's what that formula looks like. What that formula says is to find the sum of the first n terms of the arithmetic series, we're going to take the first term and the nth term, or the last term, right? So n is the end of our series. So we're going to take the first term and the last term. We're going to add them up. We're going to cut them in half. And then we're going to multiply by the number of times we did that. Okay, so that's the first and the last. We're multiplying by the number of terms, but we're cutting it in half, and it kind of, sometimes you'll see this formula written a tiny bit differently. You might see Sn equals n over 2 times a1 plus an. It's really the same thing, but it's saying we're adding up the first and the last, and then we're multiplying by half the number of terms in our series. And this goes back to that story of the kid who added 1 and 100 and then multiplied it by 50 because there were 50 pairs of 101. Okay, so another formula to add to our list, arithmetic series. Okay, we say we're going to add the first term and the last term in our series, divide by 2, and multiply by the number of terms in the series. All right, let's go ahead and try that. So our first one here, they just give us all this stuff. We're just going to practice plugging it in and then practice plugging it into our calculator. So we say, all right, my first term is 10. My last term is 31. And the number of terms is 8. So my formula, just so we have it on screen, is Sn equals n times a1 plus an over 2. All right, so we'll just plug our stuff in. So we'll say S8 equals 8 times 10 plus 31 over 2. And we can just plug that straight into our calculator. So I'll go 8 times 10 plus 31, which is 41, divided by 2, and I get 164 to be my answer. All right, not too bad. All right, now our next one is a little trickier because they give us the bit of this series, and they say that they want the 10th term, but darn, they didn't give us the 10th term. So we got to go back to what we learned earlier. We got to plug some stuff in to get to that 10th term. So let's find the difference first. So the difference is 4 minus 1, which is 3. And then we're going to go ahead and say, all right, a sub 10 is equal to my first term, which is 1, plus 10 minus 1 times my difference, which is 3. So this is going to be 1 plus 9 times 3, which is 27. So my 10th term, which I'm going to need for a second in my formula, is 28. So I had to do a little bit of math to get that, but now I can find S sub 10. So I can say, all right, S sub 10 is equal to the number of terms, 10, times my first term, which was 1, plus my 10th term, which was 28, over 2. And I can go ahead and I can just plug that into a calculator once again. So I'll go 10 times 29 divided by 2, and I get 145 is the arithmetic series sum for this problem. So it required a little more work. I had to look at the pattern right here to find the difference. I then had to use that difference and the first term in order to find the 10th term with my explicit formula from earlier. And then I could finally go ahead and calculate the series. So with these, sometimes it's a matter of trying to figure out what they gave you and what you can work with and what you can't work with. All right, our next example is a little bit different. What we're doing here is they are giving us the first term, they're giving us the last term, they're giving us the sum of the series, and they're asking us what is that n to make that happen. So once again, we're just going to use the formula. So the formula goes Sn equals n times a1 plus an over 2. We're going to plug in what we know, find what's missing. So we go 690 equals n, that's the part we don't know, times 19 plus 96 divided by 2. So it's really not that hard of a problem. So we say 19 plus 96 divided by 2, and then we say 690 divided by that number. And so we divide by that number. So I'll do a little bit more. I got 690 equaled n times, we calculated that out, I got 57.5. I'm going to divide that over. So 690 divided by 57.5, I get n equals 12. Awesome. So there was 12 terms to get to 96 in this series. All right, so one other thing we talked about before was sigma notation. So you remember from last lesson that sigma notation, this is our first term down here. It says starting with the first term, we're going to add up to the 10th term using this formula. So our first term, we'd plug in 1, and then 2, and then 3, and then 4, and then 5, and then 6, and 7, and then 8, and 9, and then we stop when we get to 10, and we add those all up. That's what sigma notation is. Now, the great thing about sigma notation is depending on how it's written, sometimes it gives us a lot of information right here. So we can figure out a couple things really fast, really easy. In sigma notation, if it is written in this kind of format right here, where it's a number times a variable plus a number, this number right here is going to be your difference. So you know that this is an arithmetic series. And so because you know that, you can use that formula that we had from before. You could use that 1 plus an over 2 times n in order to get your sum of the first n terms. Now you gotta be a little careful here because sometimes if you start with 0 instead of starting with 1, it's a little tricky, right? Between 0 to 5, there are 6 terms or something like that. So that's a little tricky, something you gotta pay attention to. But this is pretty straightforward. What you're gonna do is you're just gonna plug in these numbers right here. Plug in this number right here. That's your first term. That's going to be your 10th term. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's 10 terms that are being plugged in there from 1 to 10. So let's go ahead. Let's fill in the pieces for our formula right there. So we'll say S10 equals 10 times our first term. We're going to plug in that 1. So 4 times 1 is 4 plus 1 is 5. Plus our 10th term, we'll plug in that 10. 4 times 10 is 40, plus 1 is 41. So 5 plus 41 over 2. There we go. That's our S10. We can plug that into our calculator. So we'll go ahead and say 10 times 46 divided by 2. And we get that S10, our series here, adds up to 230. All right, let's go ahead and try one more example of this for our last example today. All right, here's our last example, very similar to what we just had. First off, I can see right away that it is arithmetic. It has that same structure as before. So we know we can use that formula. That formula, once again, looks a lot like this. It looks like Sn equals n times a1 plus an over 2. We can take our first term. We can find our first term here. We're going to take this 1, plug it in. 1 times 7 is 7. 7 plus 2 is 9. So we'll go ahead and change that to a 9 plus. And then we can get our, in this case, 12th term. So we'll say 12 times 7. 12 times 7 is 84. So plus 84. Oops, forgot to turn on the pen. 84 divided by 2. And then we got to figure out how many terms there are in this series. Now, once again, sometimes it's easier, sometimes it's harder, but we can just kind of count on our fingers. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 numbers from 1 to 12. So we could say 12, and then we can just plug that into a calculator. So right now we're finding S12. We'll plug that into a calculator, so we'll say 12 times, what is that going to be? That's 93 divided by 2. And we get that the series of these 12 terms all added up is 558. Circle that up. Now, the one thing I do want to caution you, if for some reason you have something where it's like a sum that goes from like 2, we'll say like k equals 2 to 5, be careful there. Really count it out. 2, 3, 4, 5. There's 4 terms there. So when you do your S sub 4, right, there's 2, 3, 4, 5. There's 4 things that you're going to have to add up there. So you got to be really careful to pay attention to what that N is going to be right there. All right. Now, I know that was a long video. Hopefully you made it all the way through. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.